Hello, I'm Mr. Howard. In this video we are going to look at even and odd functions. This is for my pre-calculus students. All of the examples in this video and many of my others come from bluepelicanmath.com. So for teachers, this is a great resource. It's the curriculum that I use for my pre-calculus students. It's very good, and I also use it in other math classes that I teach. It is a great curriculum, so I do want to give them a plug because they do have great stuff. All right, so even and odd functions. Let's look at some definitions and then we'll work some examples. So functions can fall into the category of even, odd, or neither. So if we have a function, it's going to be one of these three. Of course, it's either even, it's odd, or it's neither one of those. All right, so an even function, if graphically, if we look at it, it is a relation that has symmetry with respect to the vertical axis. So really, the best quickest example to look at would be a parabola, right? Parabola that is not shifted left or right because it is symmetrical about the y-axis, just like this one is. So we take what's to the right of the y-axis, we reflect it over the y-axis, and it lays on top of itself. So that is by definition an even function because it's symmetrical about the y-axis. Algebraically, we can show that f of x is equal to f of negative x, and we'll run some examples in a little while and work through this algebraically. But what it really means here is that f of x is equal to f of the opposite x. So what this is showing here, same y value is also paired with the opposite, I'm going to abbreviate that, opposite x value. So for every x value, the same y value is also paired with its opposite. So in a table you're going to see, for example, x and y, and then you'll see negative x is also paired with that same y coordinate. I mean, think about it. When x is 2 over here, let's say y is 7, so we have 2 comma 7 on this parabola. We will also have the opposite x, negative 2, is paired with the same y coordinate, 7. Okay, so algebraically, this is all this is saying. Same y, opposite x. That's the way you can think about this notation. Okay, with an odd function, the easiest one to think about there, parent function wise, an odd function is a relation that has symmetry with respect to the origin. It's got to be symmetrical with respect to the origin. A cubic graph is an odd function. And remember, odd starts with O and origin starts with O. So one is symmetrical with the y-axis, that would be even, and the other one is symmetrical about the origin. And odd starts with O and origin starts with O. So that's how you can remember that odd is symmetrical about the origin. That's one way you can do it. So we talked about graphically this cubic graph. If we reflect this portion over the y-axis and again over the x-axis, it's going to lay on top of itself. That's what we mean by symmetrical with respect to the origin. Okay, algebraically speaking, we are saying here that for every that f of x is equal to the opposite of f of negative x. So the negative of f of negative x. So the way to look at this, for every x and y in the table, we will also have the opposite y, so I'm going to abbreviate opposite y, paired with the opposite x. So when we look at a table, if we have an odd function, we will have an x and a y coordinate, and we will also have the opposite of this x, negative x, will be paired with the opposite of this y, negative y. So for example, if we look at this cubic graph quickly and we have the point, we'll just do this again, 2 comma 7, we will also have the point on the graph down here of negative 2, negative 7, right here. Okay, so if we have the point 2, 7 on this graph, we'll have the negative 2, negative 7 on the graph. Every x and y, so for x and y, the opposite of x is paired with the opposite of the y, just like this. Okay, we'll look at some examples so this will make some more sense later. But just going back to our where we were looking at our reflections, if you're reflecting about the origin, you're reflecting over the y-axis, which changes your x-coordinate, which we did here, and you're also reflecting over the x-axis, which changes your y-coordinate, which we did here. So it really makes sense. And again, we're about to look at some examples. One other major part that I need to cover about odd functions is they must have the point 0, 0 in their table. The point 0, 0 must be there. Just because a function has 0, 0 in it doesn't necessarily mean it's odd, but if it does not have 0, 0, you can count on the fact that it is not odd. So the first check you can always do is see if 0, 0 is a point on that graph. If 0, 0 isn't there, you can bet without a doubt it is not odd. If 0, 0 is there, it's possible that it is odd. Okay? Alright, so let's look at some examples. These examples. So in the following examples, is the relation an even or an odd function or neither? Well, looking at this, the drawing's not perfect, but you can see that it is symmetrical. If we just flip it over the y-axis, if we take this part right here and just reflect it over the y-axis, it would lay on top of itself, right? So that's not perfect, but if we flip the pink over, it would lay on top of the green. So it is an even function. Okay, it is an even function. Example 2, neither. Because if we flip this over the y-axis, it's definitely not going to lay on top of itself. And then if we flip it again over the x-axis, it's still not going to lay on itself. So this one would be neither. It is not symmetrical about the origin or the y-axis. Okay, example 3. Well, this one we already talked about. It's a cubic graph, so it is going to be odd. Remember, here's the way I remember it. Odd starts with O, and origin starts with O. So if it's an odd graph, it needs to be symmetrical about the origin, meaning you can imagine flipping this part, so this part right here. We flip that, I'm going to draw it in blue. We flip it over the y-axis and it ends up here. Then we take the blue and reflect it over the x-axis now. We've already reflected it over the y-axis. Now we take the blue and reflect it over the x-axis, and it's going to lay on top of the graph. So that's how you know that it is odd. One other thing that's always true, of odd graphs is that they go through the point 0, 0. It doesn't mean they're odd just because they go through 0, 0, but they cannot be odd without going through 0, 0. Okay, that's very important to understand. Okay, with example 4, the first thing that we're going to do is determine if this is even or odd. So we have x squared plus 3. Well, the easiest test to see if it's even quickly, we can just put this into our calculator. So let me pull that up. Pardon me, to see if it's odd. That way we don't have to run more than one test on it. So if it is possibly odd, if we go to x squared plus 3 and we put it in our calculator, the point 0, 0 needs to be in the table, and it is not. So there's no way that this is odd. So odd is out. So maybe it's even. So if it's even, then remember that f of x, from our rules, f of x has to be equal to f of negative x. Okay, if this is even, this has to be true. So all we do is everywhere we have an x here, we substitute in a negative x. So that would mean that f of negative x is going to be the negative of x squared plus 3. Remember, negative x squared just becomes x squared plus 3. So it does equal itself, right? It does equal this. So this one would be an even function. Even check. Okay, and we can check that in our table. Remember what we said before. We said f of x is equal to f of negative x. So when we look at a table of values, that means that if we have, let's just make a table of values here. So let's go on our table. We're already in there, right? So we have the point 1, 4 and 2, 7. So let's put those 1, 4, and 2, 7. So we've already proven this is even, but if we were just looking at our calculator table, that would mean we would expect to see for the opposite x coordinate, -1, the opposite of this one, it should also be paired with 4, the same y coordinate. The opposite of this x coordinate, -2, would have to be paired with the same y coordinate if this is truly even. So let's verify that with our calculator. So we need to go when x is -1, and we do get 4, so check there. Now let's pull our calculator up and go when x is -2, we get 7, so check, so it checks out. So we algebraically checked it, and we checked it in our table, and if you want to graph it, you can see that it does look even. Now you have to be careful looking at your graph because it can fool you sometimes, but this is even, and you can tell that it looks even in our graph picture here. Okay, next examples. Alright, let's look at example 5. So we're determining whether f of x equals 4x cubed minus x is even or odd. And we could algebraically run the even and odd tests, both of those tests on this, but to shorten our process, I'm going to use our calculator here, and I have put 4x cubed minus x in here, and I want to go ahead and check to see if there is even a possibility that it is odd before I run that test. And remember, if it is odd, it has to have the point 0, 0 in the table. So I just go in my table, and 0, 0 is in there, so it is possibly odd. There is a possibility that it is odd. So we're going to start with the odd test then. So remember, if the odd test is true, that says that our f of x must be equal to the opposite of f of negative x, right? This must be true right here. So we need to take this right here, our 4x cubed minus x, and we need to take the opposite of 4 times the opposite of x, so negative x here, cubed, minus the opposite of the x they give us. Okay, so a lot of parentheses here, so let's just evaluate the inside first. So negative x raised to the third power means negative x times negative x times negative x. So it's still negative, right? So that's going to give us the opposite of negative 4x cubed, because realize negative x, if you cube that, it's still going to give you a negative right here. And then we have negative negative here, so that's going to be plus x. Okay, and then finally we have to distribute this negative in there and there, so we have to change the signs. So we end with 4x cubed minus x. And notice that checks because we ended back with this. Okay, that's the algebraic check. Now remember, if we are looking in our table, if we make a table of values here, so we have our x and our y, if this thing is truly an odd function like we think it is, that means let's check an x coordinate of 1 and an x coordinate of 2 to start. So let's put this in our calculator, which we already have, so we go on our table. So when x is 1, y is 3, and when x is 2, y is 30. So we have 3 here and 30 here. So remember from our test, if this is truly an odd function, then we can take the opposite x coordinates. So we're going to test in our table, -1 should be, so the opposite x should be paired with the opposite y. So -1 should also be paired with -3 if this checks. The opposite x, -2, should be paired with the same absolute value but opposite sign of the y, so -30. Because this says the opposite x and the opposite y right here. That's what we said. Opposite y there, opposite x there, the way we think about it. So these points must be in that table to confirm with a table that it is an odd function. So let's look at that quickly. So negative 1 is paired with negative 3, check. Negative 2 is paired with negative 30, check. So it is an odd function. Realize, to make this faster, if you're able to use your calculator, you can check this quickly with just your calculator without going through the algebra, if you're allowed to do that. Okay, but you need to be able to test it algebraically and with the table. Let's look at our graph and see if we can get an idea. And look, it's going through 0, 0. It's a cubic graph. That was another hint. It was a cubic graph, so it had a pretty good shot of being odd. And we can see here that if we flip this over the y-axis and then this over the x-axis, we're going to lay on top of it. So it is an odd function. Okay, next, let's look at example 6. All right, so we're looking at example 6. We're asked to find is this odd, even, or neither. I do need to go back over here and say that we found that this one was odd, right? That's really our final answer, is that no, example 5 was odd. Okay, I didn't do that before. Okay, so example 6, we want to find out, is it even, odd, or neither? Remember, we could run the even test and the odd test both, but you don't always know which order, and you may end up doing a lot of extra work. So a good check is to go into your calculator, type this into y equals, and check to see if it's odd, if it has a possibility of being odd before you run the odd test, by looking for the point 0, 0 in the table, because to be odd it must have that. Just because it has 0, 0 doesn't mean necessarily that it's odd, but if it is missing 0, 0, you know for sure it's not odd. Okay, so 0, negative 1 is here, so we know this thing is not odd. So we can already say odd, no. It's not odd, so it might be even. So we want to algebraically check this. That's what we're asked to do, so let's do that. So remember, if it is even, that means that f of x must be equal to the f of negative x, right? Okay, so that means we just take everywhere we see an x here, we substitute in a negative x. That's all we have to do. So we have negative x squared plus negative x, the opposite here, cubed minus 1. So if you square a negative, you end with a positive, so this just becomes x squared. If you cube a negative, you're still going to end with a negative, so this becomes minus x cubed. And then we have this minus 1. Okay, so did we end with the same thing, x squared minus x cubed minus 1? That is not the same as this, so it is not even either. So there's no sense in looking in our table or anything, because we're going to see that it is actually neither. So the answer is neither. We checked for odd, we checked for even, and it didn't show up. All right, next example. All right, so we have example 7. Complete the table to determine if f of x equals x squared plus 1 is even or odd or neither. The domain is restricted to 1, 2, 3, negative 1, negative 2. Okay, so we just need to evaluate x squared plus 1 and then f of negative x of this and negative f of negative x of this, and at x values of 1, 2, 3, negative 1, negative 2. Okay, to make this easier, let's let our calculator do a lot of this work. So algebraically, we know that f of x equals x squared plus 1, so we can just put that in our calculator. F of negative x is going to be equal to negative x squared plus 1, which just equals negative x times negative x is still just x, so it's x squared plus 1. So that's our f of negative x. Our negative f of negative x would be equal to the opposite of negative x squared plus 1. Okay, so that is going to be equal to the opposite of x squared plus 1, which is finally negative x squared. We just distribute that negative in. Negative x squared minus 1, right? So this one right here. So let's put these in our calculator. I went ahead and did that earlier to make this faster. So we have x squared plus 1, our original, in here. We have negative x squared plus 1. That's our f of negative x right here. And then finally we have negative x squared minus 1 right here. Okay, so y1 is our original, y2 is going to be this table, y3 is going to be this column of the table. Okay, so let's just fill these in. So we need, we have two, well, let's make this a little bit easier and just drag this over, paste it in. So there's y1, y2, and let's get our y3 table in here now, and we'll drag that over here, paste that in, and then it'll make it nice and quick to fill these values in. Okay, so y1, when x is 1, it's 2. When x is 2, y is 5. When x is 3, y is 10. When x is negative 1, it's 2. When x is negative 2, it's 5. Okay, for f of negative x, that was in y2, so when x is 1, it's 2. When x is 2, it is equal to 5. X is 3, it's equal to 10. X is negative 1, it's equal to 2. X is negative 2, it's equal to 5. Okay, this is our y3 down here. So when x is equal to 1, it's negative 2. When x is 2, it's equal to negative 5. When x is 3, it's equal to negative 10. When x is negative 1, it's equal to negative 2. And when x is negative 2, it's equal to negative 5. Okay, so from the tables, looking at the tables, we need to determine if it's even, odd, or neither. Okay, if it's even, then this column should match this column. If it's odd, this column should match this column. And we can see that these two columns match. Therefore, final answer is this is even. Okay, and we already found that algebraically right there, right? Okay. One last topic your notes do talk about, is it possible for a relation to have symmetry to the x-axis? And yes, but it cannot be, we can't test whether it's an even or odd function, because realize if we have a graph that is symmetrical to the x-axis, like so, symmetrical to the x-axis, it's not a function because it fails the vertical line test. So there's no way we could test to see. It wouldn't matter if we tested to see if it's an even or odd function because it is not a function to begin with. Alright, that's it for this video. I'll see you in the next video.